Hello friends, welcome to engineering tutorial. So in the previous video related to physics of semiconductor devices, was the first video, we just studied the basic things, okay, basic introduction to what this whole subject is all about, what are the things that we are going to study, and all the basic introductory things related to the semiconductor physics, this whole subject. So in this video we are going to discuss again some basic things related to the physics of solid materials, which will come up in our discussion related to the physics of semiconductor devices. All these things will come into play there, the terminologies that we are going to cover. So that's why it's good that we just have a quick look at those basic concepts. So the physics of solid materials. Now the study of the physics of solid materials is very important because the main component, the core of this subject, the physics of semiconductor devices, which is the semiconductors, they are solid, they belong to the solid category, okay, solid, liquid, gaseous, the three types of matter there are. So the semiconductors, they are the state in which they are used in the engineering applications, it is in solid state. So all the basic principles of physics of solids are applicable to those semiconductor materials as well. So the study of the basic physics of solid, it can be divided into two parts. First, the classification of the solid materials on the basis of their structure and property, and to study the crystal structures if they have any, and again classifying their crystal structure into various categories. So basically what we need here, according to that, these are the two main parts, the two main aspects of the study of the physics of solids. It can be divided into many parts according to various other applications, but here for the discussion related to the physics of semiconductor devices, these are the two main parts which we have to understand for a semiconductor, okay. So the classification of solid materials on the basis of their structure and property can be done in two ways, into two categories. First is the amorphous solids, second is the crystalline solids. So let us understand them separately. First is the amorphous solids. So the amorphous solids are those type of solid materials in which there is no proper arrangement, or the atoms in those solids, they do not have any particular atomic arrangement, they do not follow a pattern, okay, they are not regularly arranged, they are irregular, they don't have any particular geometry about it, okay. So the amorphous solids, in amorphous solids the atoms are not regularly defined, they are not properly arranged, they don't have any proper geometry associated with them, so they do not have any pattern, okay. The arrangement of atoms do not follow any particular pattern, they are irregular, they are uneven, okay. So you cannot predict the structure of the amorphous solids. They are isotropic in nature. So what is isotropic? What does this mean? Isotropic means that the properties of amorphous solids, the basic properties, be it mechanical, electrical, optical, magnetic, all these characteristics, all these features, they are same in all directions. Okay, these properties are even, they are uniform in all directions. Okay, it means that if you pick up any amorphous solid, each and every point of that, each and every surface area of that solid will behave in the same way if we look at the various characteristic features, be it the mechanical characteristics, the electrical properties, the optical properties, the magnetic properties, whatever. They will behave in the same way throughout each and every point of that solid. Each every inch of that solid will behave in the same way. So it means that they do not exhibit any sharp changes in those properties. Okay, the mechanical, electrical, optical, they from one point to another there is no change in those properties. Okay, for example, their appearance, texture, density, melting point, boiling point, and all the other associated the resistance values or the conductance values or whatever, the mobility of ions, whatever, it will be the same in at all places. They will exhibit no change from one point to another. So that is the property of amorphous solids. Some examples: glass, plastic, wood, etc. Okay, so they come under the amorphous solids. So the main points associated with them are they do not have any proper pattern of arrangement of their atoms, they are isotropic in nature, it means their properties are same in all directions. Now the crystalline solids. The crystalline solids here, as opposed to amorphous solids, they have a proper regular geometrical pattern of arrangement of the atoms, okay, in 3 dimensions, x, y and z axis. Okay, so the crystalline solids, they have a proper arrangement following a proper geometry, a proper pattern in which the atoms of the crystalline solids are arranged, and this arrangement is repeated throughout the entire structure of the crystalline solid. Okay, it means that we can predict the structure of the crystalline solid if we understand the crystal structure, because it will be repeated throughout. A combination of those crystal structures will make the crystalline solid. Okay, and they are anisotropic in nature. Okay, opposed to the amorphous solids, they are anisotropic in nature. It means their properties, their mechanical properties, electrical properties, optical properties, magnetic properties, the basic physical properties, they are different in different directions. One point will behave in a particular way as with respect to a particular aspect, particular feature. The other point will behave in a different way. For example, the electrical conductivity at one place will be different, at other point it will be different. For example, I'm just saying the melting point of one point, at one point it will be different, at other point it will be different. The appearance will be different at different places, the texture will be different at different places. So this is what anisotropic nature of crystalline solids means. Okay, and this is this anisotropic behavior of crystalline solids which gives rise to various interesting effects which are used in various engineering and technology applications. For example, the piezoelectric effect, where when a pressure is applied perpendicular to a piezoelectric material, which is a crystal material, quartz, tourmaline, rochelle salt, whatever, then it produces a voltage at the ends of the crystal. Then we have the Hall effect. Then we have the polarization of light, where all the light vectors, electric vectors of light, when passed through a particular crystal material, all the electric vectors are confined to one plane. So all these effects, and there are many other effects, they are the outcome, they are the result of this anisotropic behavior of crystalline solids. And metals and semiconductors, all metals and semiconductors come under the category of crystalline solids. That's why they are very important. Okay, So this is the basic categorization of the amorphous and crystalline solids. And the reason why I discuss this, because in the upcoming videos when we'll discuss the various aspects related to the physics of semiconductor devices, we will be using these terms: crystalline, the anisotropic, isotropic, or the regular pattern arrangement, so whatever, so that in order to understand that, we need to have a good understanding of the basic physics of solid materials. Okay, so here we have discussed some basic things related to the study of the physics of solids, the aspects, then the classification of solid materials, the basic concepts related to amorphous and crystalline solids, and the result that we got is that the semiconductor materials that we are going to discuss, they fall under the category of crystalline solids. So the result is that they will have a proper pattern or geometry of the arrangement of the atoms, the semiconductor materials. Then they will exhibit anisotropic nature, anisotropic behavior. It means their various properties will be different in different directions, and there will be changes in those properties from one point to another. So these are the things, the conclusions of this discussion. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.